I only have 10 Easter chocolates left. There's 4 M&Ms, 4 Eggies, 1 Reese egg, and 1 peanut butter cup. You can see them here. So it's a Reese peanut butter cup, a Reese egg, these are the Eggies, and then 4 M&Ms. I conveniently selected them so that there's one of each color that we're picking from here. So if I divide them equally and at random, what does the probability distribution look like for the number of Eggies I get? Because they're my favorite. So I've created a probability distribution table to start. So we have over here in the left-hand column the number of Eggies. So obviously if I randomly select 5 treats, I might not get any of my favorite Eggies. So the probability that this would happen is 6 choose 5 divided by 10 choose 5. So the numerator, 6 choose 5, comes from only choosing no Eggies, only 1, 2, 3, 4, 5, 6 of the candies are available to be chosen. I get 5 of them because I don't get any Eggies, and the denominator 10 choose 5 is because I can pick from any of these candies 5 of them. So that gives me 6 over 252, which gives us this wonderful decimal place answer as an approximation there. I might also at random get 1 Eggie. So that means from my 4 available, I'm going to choose 1, and then from the 6 other candies, I choose 4 of those, because 1 Eggie and 4 other candies totals to 5. The denominator remains 10 choose 5, which gives me 60 divided by 252. I could also luckily get 2 Eggies, meaning I get 4 choose 2. So out of the 4 Eggies, I'm randomly choosing any 2 of them. And then from the remaining 1, 2, 3, 4, 5, 6, I am choosing 3 of those candies. And then the denominator remains 10 choose 5. So that gives me 60 options divided by 252. My apologies, not 60, 120 options over 252. Seems like the highest probability to me so far. I could also get 3 Eggies randomly in my pile of 5, which is 4 Eggies, choose 3 of them, and then from the 6 other candies, choose 2, which gives me 4 times 15 over 252. And if we notice, that's the same number that we got earlier in our chart. And then lastly, I could get 4 Eggies. 4 choose 4 times 6 choose 1 divided by 10 choose 5, because I'm getting all 4 of the Eggies and 1 other candy. Now it's important to note in this probability distribution that I cannot get 5 Eggies because there aren't 5 available. But in some circumstances, if there was enough available, 5 would definitely be included down here in that chart. So we're going to let capital X be the number of Eggies that I randomly get. So that means that Px, or the probability of the event we're going to talk about, is the probability of getting X Eggies. So our probability distribution then would look like this. So the probability of getting X Eggies, we're either getting 0, 1, 2, 3, or 4, where X is the number of Eggies we're getting, and then we had to work out our probabilities. So the first challenge here is to figure out a scale. So I basically counted the number of boxes, or lines in this case. I got 10 lines, so I figured 0.5 needed to be somewhere at the top, and then I made it clear that the smallest bar would actually have some height to it. So you want to make sure that you can actually see the height of each bar, but then you also don't want to go off the page. We want to make sure that this is not a misleading graph. So as we can see, it's not very likely that I get no Eggies, but unfortunately for me, it's not very likely that I get 4 Eggies, since they're my favorite. Most likely, I'll just get 2. So the typical follow-up question that you might get after creating a probability distribution chart and graph is, what is the probability that I get mostly Eggies? Now, mostly Eggies would imply 3, 4, or 5 Eggies, because obviously if I only get 2 or 1 or 0, that's not most of them. So I can't have 5. That means I either get 3 or 4. So the probability that I get 3 Eggies plus the probability that I get 4 Eggies, I added the height of this bar plus the height of this bar. Or you could think about it that I added 6 over 252 plus 4 times 15 over 252 together, and I got 11 over 42. So you usually want to try and get that as an exact value like I have here, and then interpret that as a final answer, 26.19%. So my conclusion to this would be that the probability that I would get mostly eggies is 26.19%, which is not good for me because they're my favorite.